You're welcome, learners. Today we are going to discuss about the concept behind the projectile motion. Projectile motion is an example of two-dimensional motion. Okay, what is projectile motion? Projectile motion is when the particle is thrown obliquely near the Earth surface. It moves along the curved path. Okay, such a particle is called projectile and the motion is called as projectile motion. Okay, here we assume that the particle is closed at the earth's surface so that we can take gravitational constant as g. Okay, and the acceleration of the particle is constant. Okay, so in this video we we understand about the projectile motion and derive some important relations, that is the Hmax, range, time of flight, equation of trajectory also, and then at last we do some important problems so that we can understand it better. Okay, so let's start. But before going starting, we have to understand what what is the meaning of Hmax, what is the range, what is the time of flight. Okay, so firstly, let us first make ourselves familiar with certain terms used in discussing projectile motion. Okay, here we throw a particle from the origin with initial velocity u in direction which making an angle theta with the horizontal surface of the earth, and after some time, due to gravitational force, it traces the path like curved like a parabola. Okay, so here the maximum height attained by the particle is called the Hmax, which is the maximum height, and range is the maximum displacement covered by the particle in the direction of the surface, or in the x-axis, or in the horizontal surface, or the max. Hmax is the maximum distance in vertical direction, and range is the maximum distance in horizontal direction. Okay, and what is the time of flight? Time of flight is the time which is consumed by the particle to perform the whole projectile motion. Okay, when it start, let us assume that the time t is equals to 0, and at another point like this, it is at a time t, and the position and position of the particle will be like this. Okay, and at the time stop, it stops, the complete time taken by the particle to complete the whole motion is called the time of flight. Okay. Okay. The the total time taken by particle to particle to complete the projectile motion is called the time of flight. Okay. And what is the equation of trajectory? Equation of trajectory is the equation of the particle or the path traced by the particle in completing the projectile motion. Okay. Equation of trajectory gives the information. Equation of trajectory gives the information about particle at any time instant t. Okay. So let's start with a particle having initial velocity u, which is making an angle theta with the horizontal surface of the earth, like that. This is the vertical axis and this is the horizontal axis, and this is our particle. Here the particle moving with the velocity u, having an angle theta with the horizontal surface of the earth. And if we resolve this velocity u in the component of x and y, then it will becomes the component along the x-axis will become ux is equals to u cos theta, and the component along y direction will be is equals to uy is equal to u sine theta. Okay. The direction is upward direction and direction is along the x-axis. The maximum height, which we called Hmax, and the maximum distance covered along the x-axis is called as range. Okay. We have to find what is Hmax, what is range, what is time of flight, and what is the equation of trajectory. Okay. इसके अलावा to find these values we use the equation of kinematics, so that in this through this lecture we can understand how the kinematic equations of motion can be used. Okay. Here this is the origin or this, and in this projectile motion we assume some things like the gravitational force acting on that particle is the earth's gravitational force, so that we can take gravitational constant g. Okay. Whose direction is downward. Okay. Here the point of projectile is this origin, and the frame of reference is our earth, And the kinematics equations are v is equals to u plus at, s is equals to ut plus half at square, v square is equals to u square plus 2as. You are familiar with these equations in the one-dimensional motion also. And again, I will remember you that v is the final velocity, u is the initial velocity, a is the acceleration, t is time, s is displacement, u is initial velocity, t is time, s half is constant, a is acceleration which is also constant in this motion, t is time, v is final velocity, u is initial velocity, 2 constant, a acceleration or s displacement. Okay, so then, so as indicated in the figure, the acceleration and the motion along the horizontal direction, there is no acceleration or g working on the particle, and in the vertical direction there is a g which is acting on the particle in the downward direction. Okay, so we understand the whole motion, projectile motion, into separately into the two horizontal and vertical parts. Okay, so we also resolve this velocity in two components. U initial velocity is u cos theta and final velocity in along the vertical direction will be the u sin theta. So for determining these relations, we have to understand it in separately. So let's start the horizontal motion. In horizontal motion, acceleration is 0. Okay, so from the kinematic equations, v is the final velocity which is 0 नहीं होगी, the v cos theta is equals to u cos theta plus 0 due to a is 0. Okay, second equation will be s is the displacement along the horizontal motion along the x-axis. Okay, so we can write s as x is equals to u cos theta t plus 0. Okay, so here we have x is equals to u cos theta t, an important equation which is used in further calculation. We can take it as a equation number 1. And the last one is also v square is equals to u square plus 0. So it is not for important for us. So let's move forward along the vertical motion. Okay, the vertical motion. Okay, here one thing is that the motion of particle in horizontal direction is seen as the particle start from here point this, and after time t it comes to at t equal to 0, t equal to t final time tf. Okay, and the motion, vertical motion, is described as the particle start from a point this going upward and reach some maximum height, and again come backward through along this path also. Okay, along this path. Okay, so initial point and final point of the initial position and final position of the particle in vertical motion is same. Okay, here acceleration is equals to the particle goes in upward direction, so it opposes the gravitational force, so that we take the acceleration as negative of g. Okay, okay, so what will be the kinematic equation for this motion? For this, v is equals to u plus at will become, so v is the final velocity along the direction vertical, and in vertical direction there is a term sine theta along this. So v v sine theta is equals to u sine theta minus gt, which is equation number 2. Second equation, s is equal to ut plus half at square, and s is what? S is the displacement in y direction, so we can take s is equals to y. So y is equals to u is the initial velocity, and initial velocity of our particle is u sine theta. Okay, so y is equals to u sine theta into t, and negative of half g t square is the given name as equation number 3. And the last one, v square is equal to u square plus 2as, which can be written as v sine theta का whole square is equals to u sine theta का whole square minus 2gy, because s is the displacement in the y direction, so we can take s as a y. Name this equation as equation number 4. So let's move forward and find values of Hmax, range and time of flight, and equation of trajectory from these four equations. So for finding the maximum height, which is along the vertical motion, which equation can be used? You see that in first equation there is no term which comes as a displacement term. Okay, so second equation cannot be used. In the equation number 3, we see that there is a term y which will become our maximum height. So we can take this equation, but in this equation there is an unknown term which is time t. So we should check another equation. Let's see the equation number 4, which also has a displacement term y, and there is no another constant, so we can use the equation 4 directly to find the maximum height. Okay, so let's start. 4 for determining the Hmax. For determining the Hmax, we use equation number 4. In equation number 4, we know at the maximum point the velocity of the particle is 0. So in this equation, this term is 0, then this whole term will become 0. So equation 4 it will equals to 0 is equals to u sine theta whole square minus 2g, and y at this position, y is what? Y is Hmax. So we can write y as Hmax. Okay. Then after rearranging this equation, we get the answer. So take this term here, Hmax 2g is equals to u sine theta the whole square. So Hmax will be equals to u sine theta the whole square divided by 2g. This will be our one result. Take this equation number 5. Okay, so move forward and try to find the another relation. Mm, so we can find out the time of flight from which equations we can find time from the equation 1. We can find the time from equation 2 here because the term t is come. We can find the time from the equation 3. Here the t term has a quadratic form and we cannot use the equation 4 because it has nothing about. So for determining the time of flight, we use equation 3. Okay, we use equation 3, and we know the whole journey, the time taken by the particle, okay, is the time of flight. Okay, and we take the equation from the vertical motion. Okay, vertical motion. So in the vertical motion, the initial position and the final position of the particle is same, so the displacement along the vertical direction will be 0. Okay, so we can take the y as a 0, and the initial velocity is u sine theta, and the time taken to whole journey is t minus half g t square. Okay, on taking commons t, here remaining u sine theta minus half gt, which is equals to 0. Now we know the two quantity in the product is equals to 0, then they will become separately equals to 0. That is, if the t is equals to 0 or u sine theta is equals to half gt. On further solving it, we can find t is equals to 2 पर चला जाएगा, g नीचे, तो 2 u sin theta upon g. This is our result. We know in the whole journey the particle takes some time, so it should not equals to t is equals to 0. Okay, not possible. Then the total time taken by the particle in the whole journey will become t equals to 2u sin theta upon g, which we can take equation number 6. Okay, now move further and try to find the another relation like range, from which we can find range. Range is the maximum displacement along the x-axis or the horizontal motion. In the horizontal motion, we know the x is equals to u cos theta t, equation number 1. Here if we know the t, we can find out the x. Okay, if t is the total time of the journey, that is the time of flight, then x will give us the range of the motion. So on putting the value of t from the equation last we derived in the equation 1, we can find out the range. Okay, so for determining the range of the particle, we use equation 1 and equation 6. Okay, to put the value of t in the equation 1, we can find range. So when t is the time of flight, x will become the range. So we can write range is equals to u cos theta into t, which is 2u sin theta upon g, will become, after solving, we see that u and u product u square, 2 sin theta cos theta will become sin 2 theta on g. So range, we get our answer. The range of our particle is u square sin 2 theta over g, which we take equation number 7. Here we know that the 2 sin theta cos theta is equals to sin 2 theta. Okay, so at last we have to find out the last thing is the equation of trajectory, from which we can find the equation of trajectory. Equation of trajectory is the equation which describe the whole motion of our particle. That is, we can find the horizontal or the vertical value position of the particle at any time instant t. So we use the both of the equation of the motion. So we can use the equation number 1, which is the position at any time t, and the another equation as equation number 3, which is the position of the particle at any time t in the vertical motion. So put the value of t from equation 1 in the equation 3, we can find the equation of trajectory as we have done here. From equation 1 and equation 3. Okay, this will be so x is equals to u cos theta t. From this, t will become x upon u cos theta. Okay, and equation number 3 is the y is equals to sin u sin theta t minus half gt square. Put this value of t in this equation, then we can get y is equals to u sin theta into x upon u cos theta minus half g t का स्क्वायर, यानी कि x अपॉन u cos theta का स्क्वायर. After solving, u से u cancel, sin by cos will become 10 and x is this minus half g x square as it is. This is the equation of trajectory, and this equation gives the value of the position of the particle at any time instant. Okay, in this, if we know the value of x or the position in the horizontal direction, then we can find the position in y direction also. This will be helpful for us. Let's see some questions which are come in the various exams based on the projectile motion. After doing these questions, we can understand it better. Okay, so let's start question this, which comes in the JE 2013. What will be the question? A projectile is given an initial velocity of I plus 2j meter per second, where I is along the ground and j is along the vertical. Okay. If g is equals to 10 मीटर पर सेकेंड स्क्वायर, द इक्वेशन ऑफ इट्स ट्रेजेक्ट्री इज, यानी कि इसने हमसे पूछा है इक्वेशन ऑफ ट्रेजेक्ट्री. वी नो द इक्वेशन ऑफ ट्रेजेक्ट्री एज y is equals to x tan theta minus maybe minus g x square upon u cos theta का square. Now from this velocity term we see that ux is equals to u cos theta is equals to I cap, and I cap means 1 magnitude, and uy is equals to u sin theta, which is equals to 2. Okay, so if we divide u sin theta upon u cos theta, u sin theta upon u cos theta, so u से u cancel, tan theta will become u sin theta is 2 and u cos theta is 1, that is 2 upon 1, that is tan theta is 2 and u cos theta is 1. Put these values in this equation. We have to find y is equals to x. Tan theta means tan theta value is 2 minus half g x square upon u cos theta 1, and the value of g also given as 10, so we put here 10. Okay, so after solving 2 से 10 5 times, 1 का स्क्वायर 1 ही हो जाएगा और ये हो जाएगा, ये विल बिकम 2x minus 5x square. This is our answer. What is the answer? This is our answer. Now let's see the another example as the maximum range of the gun on horizontal terrain is 16 km. If g is 10 meter per second, what must be the muzzle velocity of the shell? यानी कि maximum range given है 16 km per second, sorry 16 km. So here we derive the formula for range. So what is the range? Range is equals to u sine 2 theta upon g. Here this is called as maximum range, and maximum value of sine theta will, which what, maximum value of sine theta is 1, so this term will become 1. So maximum range will be u square by g. Here range is given 16 kilometer, that is 10 to power 3 meter, is equals to u square upon g. Value of g also given as 10. So from that, and asking the velocity of the shell, that is the initial velocity u. Okay, take this here, and after resolving it, it will become u square is equals to 16 into 10 की पावर 3, और ये 10 इधर चला जाएगा तो एक और 10, तो यहाँ से u is equals to under root of 16 into 10 is to power 4, which will become 4, 16 का 4 हो जाएगा और 10 की पावर 4 का हो जाएगा 10 की पावर 2 मीटर पर सेकेंड, और u is equals to 400 meter per second. Our answer, that is option A, is the correct answer. Thank you so much for watching this video. This is the first video posted by me and making by me, so